Okay, so if you could not make the office hour today, I'm recording it. Someone's asking about number 30 on 3.4. So we are finding the equation of the tangent line at 2,8. In order to do so, instead of taking this derivative using a bunch of derivative rules, we're going to use logarithmic differentiation. So we went ahead and rewrote this whole expression using logs. And now, once you have everything split up into their own separate terms, you can go ahead and take the derivative implicitly. So when you take the derivative on the left, the derivative of the natural log of y would be 1 over y. But remember to chain on the dy dx. And then kind of work your way through. If you want to just go 2 over x, that's fine. Kind of depends on your comfort level here. I usually will just put the coefficients in. Now remember, the derivative for the natural log of u is u prime over u. So I'm going to take u prime divided by u. And then for this last term, I'll have twice, and then again, u prime over u. And on the right-hand side, I only have x's, so I don't need to worry about any dy dx's on the right. So now I'm going to go through and simplify what's on the right. There's not a whole ton that we can do. We'll just try to make it look a little bit better. Whatever you do, don't cancel out these 3's. You cannot do that. You can't factor it out of the denominator, therefore you can't cancel it in the fraction. Okay, now the whole point is we're trying to get dy dx. So to get to dy dx, we're going to multiply both sides of our equation by y. So that whole thing is going to get multiplied by y. When we do that, these y's on the left will cancel, and we'll just be left with dy dx. And then we're going to take our y that we multiplied by here, and we're going to switch it back because we want everything written in terms of x. So I'm going to keep my x expression here, this factor of x, and then the y is going to get replaced with x squared times the square root of 3x minus 2 divided by x minus 1 quantity squared. So 2 over x plus 3 over twice 3x minus 2 minus 2 over x minus 1 times x squared times the square root of 3x minus 2 divided by x minus 1 quantity squared. So this was a great one to do, by the way. We're not done, but this problem combines a lot of things. And if you have questions, let me know. So this is your derivative. We're trying to find the slope at the point 2,8, and then once we get the slope, we can just write the equation using our point slope form. So we're going to evaluate this at the point 2,8, and in our case, we only have x's, so we just need to worry about x being equal to 2. So be very careful with how you evaluate this to find the slope. So I'm going to take 2 over 2 plus 3 divided by 2 times 3 times 2 would be 6 minus 2. Don't forget your parentheses. 2 minus 1. And then this whole thing gets multiplied by, let's see, 2 squared. The square root of 6 minus 2 is going to be the square root of 4. 2 minus 1 squared in the denominator. Use as many steps as you need to here to simplify this expression. And I'm going to double check just to make sure everything got properly substituted here. 3 times 2 is 6. We'll subtract off 2. There's a 2. 2 squared. 3 times 2 is 6. Minus 2 is 4. Okay. So far, so good. 1 plus 3 divided by 6 minus 2 is 4 times 2 is 8 minus 2 minus 1 is 1. 2 over 1 is 2. 4 times 2 is 8. 2 minus 1 is 1. Squared is 1. We'll simplify. All right. 1 plus 3/8 minus 2 quantity times 8. I'm getting negative 5. Here's 5. Okay. That's your slope. Now to get the equation of the tangent line, remember that at the way beginning of the problem, I told you the point was at 2,8. So you're going to take y minus y sub 1 is m times x minus x sub 1. And there is your equation in all of its glory. That's officially your answer. Oh. Okay, so that was a great one to go over because, like I said, it used a lot of rules in one problem. A lot of concepts were covered there. So that was number 30 on 3.4. Let me see, I have a blue dot in the chat. Oh, I didn't even see that, Patricia. I am officially recording now. So in case you get disconnected or in case you can't stay the whole time, we are officially recording. Yeah, I have this problem where I hit the record button and then sometimes it swirls around for like a minute and I always think it's not actually recording yet. And then I sit there at the beginning of my video just doing this. So if you ever end up starting an asynchronous video and I'm just sitting there twiddling my thumbs, it's because I don't think it's actually recording yet. But it usually is. Okay. Other questions from the chapter?
Okay, for me, I had problems during the simplification on 3/3's number 13. I actually managed to do number 14, the one after it, which was more complicated, but something about the simplifying, I think I got wrong.
On 3/3, you said?
Yeah, on 3/3 for number 13 on the homework.
Okay. Let me see here. All right, so mine is y squared plus the inverse sine of y equals 7x. The only thing iterating in this problem was the 7, so yours might be a different number. Use implicit differentiation to find dy dx. And it looks like the answer that they entered, well, it's not very simplified, but I don't think you're going to be able to do a whole lot with this one. Did you, I'm curious now though, Greg, did you enter something and it wasn't accepted? Or you weren't, or it was accepted, but you weren't sure how to get it simplified further?
No, when it was, I don't know, it might, I completed the entirety of 3/4 after it and just kind of skipped over this one, but, where was the last line that I got? Yeah, okay, so, like, when I would, yeah, I don't know how to describe it, but I got into a situation that, I don't think I could simplify that well at all, so...
You got into a big mess.
Yeah.
Okay.
So right, I think it might have been in the process, but...
All right, let's see if we can figure it out. Okay, so we're just finding dy dx. So let's see, we'll have 2y dy dx plus. Now the derivative for the inverse sine y is going to be u prime, so the derivative of y in this case, which is dy dx, divided by 1 plus u squared, which in this case is 1 plus y squared. And that's going to be equal to 7 on the right-hand side. Okay, now I want to get all the dy dx's on one side and all the non-dy dx's on the other side. This looks really confusing the way that it's written. If you want to factor the dy dx out now, and then we'll kind of work on simplifying what's left, that's probably going to be the easiest thing to do. If you do that, you'll have 2y plus 1 over 1 plus y squared equals 7. And again, if you have questions, please just ask away. Okay, so now to get dy dx by itself, we can go ahead and divide both sides by this quantity. If you feel like this looks really confusing and you want to simplify this first, you can always combine these and get at least just one fraction right now. It's kind of up to you because no matter what, we're going to have to simplify a complex fraction. So I might just leave it and then we'll just kind of work with what we're left with. You know what? I just thought about something. I forgot my radical. And I forgot my subtraction. I was treating this like an inverse tangent. Oh my goodness, you guys. It's definitely an inverse sine. Yikes. That is going to make a big difference to us. Okay. Thanks. All right, I'm going to give you a second to fix that. Oh, all right. Square root 1 minus u squared. So if you were sitting there like, how did she get that? You can always ask. I sometimes do weird things. I am also talking while I'm writing, so sometimes there's something else going on in my head while I'm writing, and it makes a difference. Okay, so to simplify this, we'll multiply every term by the LCD, because right now we have a complex fraction. So the LCD in this case is going to be the square root of 1 minus y squared. So every term is going to get multiplied by the square root of 1 minus y squared. Now, if you want to show every single step, this is what that would look like. If you feel comfortable just automatically saying, okay, obviously those two are going to cancel, that's fine. I don't need to see every little teeny tiny thing. I mean, obviously the whole point of multiplying by the LCD is to get rid of that denominator. And we should end up with this. Let's see. Yeah, and that's, I mean, that's how they left theirs too. I mean, they would have probably accepted it as a complex fraction, but I wouldn't have on your test. So this is how it should go. And this is another good one to go over. Glad we asked about that one. Does anyone have a question about this one or any other questions? Number 15 from 3.3. Okay. All right, find an equation. Yes. Okay, find an equation for the tangent line to the graph of y equals the inverse sine of x over 7 at the origin, which is going to be 0, 0. And then there's a part B, which is graph the equation and the tangent line, which I can show you on Desmos if you'd like. Okay. Check my dot situation. All right. Okay. All right, so find an equation for the tangent line. So we're finding the derivative. So y prime in our case, we're using the formula for the inverse sign, which is u prime divided by the square root of 1 minus u squared. So if you think about u as being, instead of x over 7, if you want to think about it as 1/7 x, you'll probably have an easier time just looking at it. And then that means that u prime would be 1/7, or du dx, however you want to think about that, is going to be 1/7. So to get our derivative for the inverse sign, we're going to take 1/7 divided by the square root of 1 minus, and then u squared is going to be, if you want to write it as x over 7 squared, that's fine. If you prefer to write it as 1/7 x squared, then do it that way. And we're only looking at x here on the right-hand side, so you don't need to worry about any sort of dy dx occurring here. Remember, y prime is dy dx, so you officially have dy dx equals this quantity. Now, you're really just being asked to find the equation of the tangent line. I always like for us to be able to just simplify these derivatives first because it's good practice. So I'm going to bump this 7 into the denominator. And then that will leave us with the square root of 1 minus, well, 1/7 squared is 1/49th. And then x squared is x squared. So 1/7 x times 1/7 x is 1/49th x squared. Now there's your derivative. It's if you want to simplify this, fine. If you don't, fine. I mean, technically you could work with this 49. It would make your life a little bit easier when you simplify. You don't have to, but it might make the simplification easier in this case. So if you think of 1 as being 49 over 49, just move that x squared into the numerator. You can do that, and then you'll have 1/7 times the square root of 49 minus x squared divided by 49. And you might find that this doesn't make it simpler enough that you find it worth it, and that's okay too. Remember that you can break up a quotient inside a radical as the quotient of 2 radicals. And then you can cancel out these 7s. And again, you may want to do that. It does not matter to me. I just feel like your simplification is slightly easier because you're not dealing with as many crazy things going on in your denominator. Okay, we're looking at this at the origin. So let's go ahead and evaluate this at x equals 0. And when x equals 0, we're looking at 1 over the square root of 49, which is 1/7. All right, so there's your slope. And then we'll take y minus y sub 1 equals m times x minus x sub 1. And then you'll end up with y equals 1/7 x. Now y equals 1/7 x, you should be able to graph pretty easily. But the other function you're going to have a hard time with. So I'm just looking at the graphs that you're being given in the MC and looking to see if one of them, I mean, it's a multiple choice, and I'm not going to have you graph these on the test. I'm trying to see if one of them looks like it's super obviously 1/7 x. It's kind of hard to tell. I think 2 of them have the same tangent line. Oh no, there's one option that it has to be. So there are 2 graphs that have a slope of 1/7, and only one of them is tangent to the curve. So you should be able to do that. Also in your graphing calculator, you can always pop in your inverse trig function and check it that way. So your inverse trig function was inverse sine x over 7. So your inverse sine is second sine. And then you can enter x over 7. And then you can even enter the equation for your tangent line, 1/7 x. And I'm just going to zoom standard because who knows what we're going to be dealing with here. And there's your inverse sine function, and there's your tangent line. So you pick the graph. Other questions on that one or questions on other homework problems? Go ahead, Morgan.
Can you do 15 from 3.4?
Sure. I'm glad you're asking 3-4 questions because I was sort of alarmed last night when I looked at my YouTube page and saw that there were only 17 views on my 3-4 video. There are 25 students in the class. And I was dismayed. That happens to us. Sometimes we get dismayed. Number 15 on 3-4. Find the derivative. Y equals the natural log of x to the 1/3 power. That's mine. It looks like the only number that iterates here is the denominator, minus 3. So we're taking the derivative and we're going to use the chain rule. So we're going to take this derivative as though we had x to the 1/3, but then when we chain on the derivative of the inside function, we're going to be chaining on the derivative of the natural log of x. So y prime is 1/3. Keep the inside function the way it is, subtract 1 from the exponent, and then multiply by the derivative of the inside function. The derivative of natural log x is 1/x. And then it's just a matter of simplifying this expression. So the 3 and the x are already in the denominator. In order to make this 2/3 a positive exponent, I'm going to also move the natural log into the denominator. So the 3 and the x are already there. And then we'll just take natural log x to the positive 2/3 power. So that is what that derivative is going to look like. Questions on that one or any other questions? I know sometimes students just come onto the office hour to see what everybody else is going to ask. All right, number 17 from the review. Sure. Let's see. Right, this looks like a good one. This one, it looks like doesn't even iterate. Everybody should have the same one. Natural log x plus natural log y equals x cosine y. So this is great because it not only has natural logs in it, but it also has use of the product rule. This is a really good one to do. All right, so the derivative of the natural log of x is 1/x. Thanks. The derivative of the natural log of y is 1/y. Don't forget to chain on the dy dx. Set that equal to, we're going to take the derivative on the right-hand side using the product rule. So f prime g plus f g prime. So f prime is 1, and then times g. Now remember, when you're doing f prime g, you're not taking the derivative of g, so you don't tag on the dy dx. Plus f, and then the derivative of cosine y is negative sine y. Now here you chain on the dy dx because you're actually taking the derivative in this case. Trying to get my screen just the way I want it, and I keep failing miserably. Okay, so now we're gonna go through, I mean, we'll simplify the right-hand side because, I mean, it just doesn't look great right now, but not a whole ton to do to it. Now we're gonna move all the dy dx's to one side. So I'll probably just move them to the left. And then on the right-hand side, we'll have cos y minus, and then we'll take off that 1/x term on both sides. We'll factor out the dy dx. And then we will divide. And then we'll go ahead and simplify by multiplying every term by the LCD. The denominators that you have are y and x. So your LCD in this case is going to be xy. So we're going to take all of these terms and multiply by xy. And whatever you need to do to make that clear so that you can see what's happening. And remember, the whole point of that is that your denominators are going to go. So that leaves you with xy cosine y minus y divided by x plus x squared y sine y. They factored out a y from the numerator and an x from the denominator. You can do that if you want to. You certainly don't have to. This is perfectly acceptable. If you did factor, it would look like this. Which is the same thing. Oh my gosh. It's like crazy hot, you guys. Other questions? I feel like I'm going through these a little quickly, but I guess I'm just doing that because I know that you might have a lot of questions and I want to make sure I get to everybody's questions.
I have a question.
Sure.
How do you do number 20 and 3.4?
Number 20 and 3.4. You would like me to go over it?
Yeah.
Okay. Where did I leave my 3.4? Too many windows open. There it is. Okay, number 20. All right, more natural logs and more implicit differentiation. Always leave some extra space for these ones. Number 20. Use implicit differentiation to find y prime. This is x ln y plus y ln x equals, mine's a 3, yours might be a different constant. It's not going to make a difference anyway, because when you take the derivative of that constant is going to be 0. All right, you're going to use the product rule twice because you have a product in the first term and you have a product in the second term. So for the first term, when we take f prime g plus fg prime, well, f prime is 1. And again, I'm just writing this so it's super clear in my notes. F prime g. And remember, with the g, I'm not tagging on dy dx because I didn't take the derivative of g. I just rewrote g. F prime g plus f, and then g prime, well, the derivative of the natural log of y is 1 over y. Now here's where you took a derivative of y with respect to x, so you have to chain on the dy dx. And that's the derivative of x ln y. Now for the second term, here's the first term. We're going to do the same thing. F prime in this case, though, we're taking the derivative of y. That's dy dx. It's technically 1, but it's 1 dy dx. So f prime g plus f g prime. And in this case, when we have the g prime, we don't need to tag on anything because it was with respect to x. And then f was just being rewritten. We didn't take the derivative there. The derivative of 3 is 0. Questions so far? So I'm going to simplify this a little bit. Again, there's not a whole ton we can do except just rewrite it to make it look a little bit nicer for us. Sometimes the way that we rewrite it is extremely helpful to us. Just looking at it a certain way helps us to see things more clearly. Okay, so I'm going to leave all the dy dx terms on, I guess, the left, might as well. So I'm going to keep these dy dx's on the left. Everything else I'm going to move to the right. So those are going to get negative signs on them. So the two non-dy dx's, when I move them over, change the side, change the sign. Now I'll factor out the dy dx. That leaves you with x over y plus ln x. Rewrite the right-hand side. And divide both sides by this factor on the left. And this is almost done. At this point, we just need to simplify this complex fraction by multiplying each term by the LCD, which in our case is x times y. You have an x in this denominator and a y in that one. So I'm going to show each term multiplied by xy. I'm kind of careful to put parentheses around both of these because I don't want it to look like xy minus lny. It's getting multiplied by negative lny. And then again, I don't want it to look like the xy is getting multiplied by this x inside the natural log. So just adding some parentheses around that natural log x so it's very clear it's getting multiplied by the whole natural log. Okay, so let's simplify. Those x's are going to cancel and these y's are going to cancel. This leaves you with negative xy ln y minus y squared. I'm going to guess they factored a y out of there. We'll find out in a minute. Divided by x squared plus xy ln x. Okay. And yeah, if you'd like, you can factor out a negative y. Up to you. Go ahead, Morgan.
How did you get an ln in the denominator?
This one?
Yeah.
So that one, let's see, I'm going to trace it back. This one was from here, which was from there, which was from there, which was from there. It came from this term when I took the derivative, and we did f prime g plus f g prime. So in that case, f was y and g was ln x. So f prime, the derivative of y was 1 dy dx. I could have written it like that. F prime g f g prime looks like that. So then that just kind of got carried down to here, to here, to here, there, there, and there. Oh, sorry. There, there, and there. Does that make sense?
Yeah, I just missed that step.
Okay. Yeah, that's the unfortunate part is if you're going to miss anything on these, it's usually right at the first line, and then everything else is dependent on that. They didn't even they just took a negative and put it out front, but it doesn't matter. This is perfect if you want to leave the negative in the numerator. I was just noting the way they left it was they took the negative and factored it out of the numerator and just left it in front of the fraction. Now that's fine. If you do that though, it's going to look like that. So all of these forms are equivalent. Because this is kind of just like saying, okay, we'll distribute it to both terms. This is fine, as long as it's clearly in the numerator. Yeah, so going back to the beginning, yeah, just that part where you're taking the derivative, that first thing you do, that's key. Everything's got to be there, or all the work you do after it is going to be screwed up, unfortunately. Other questions on this one, or other questions? Number 8 from 3.4. Sure. Find the derivative. Y equals 1/4 ln 2 plus x divided by 2 minus x. So yours might be different in that you might have something other than a 4, and you might have a different number than a 2. This happens to be the one that I have. Now, the 1/4 in this place works as a constant multiple. So whatever your derivative is, it's just going to get multiplied by this 1/4. So that's just going to tag along. I saw some people on the last test using the product rule with this. You don't need to with a constant multiple. I mean, technically it would work because you're just taking f prime, which in this case is 0. So 0 times g would still be 0, and then plus, and then fg prime is really all we're doing here anyway. But don't do more work than you have to. It doesn't need the product rule because 1/4 is not a function of x. It's just a constant. So if I were you, I would probably split up this natural log. Otherwise, you're going to have to use the quotient rule. So I don't want to write y prime yet, actually, because I'm just going to rewrite the expression first. So I'm going to leave the 1/4 where it is. And then instead of writing the natural log of a quotient, I'm going to use that quotient rule for logarithms that allows me to write that as the difference of 2 logarithms. And because I'm going to have 2 terms, I want to make sure I use some grouping symbols so that I note that properly. So this is going to be the natural log of 2 plus x minus the natural log of 2 minus x. And that whole quantity is getting multiplied by 1/4. Now, again, the 1/4 is a constant multiple, so it's just going to get multiplied by whatever this derivative is. If you want to distribute it, fine, but you don't have to. So you can just apply it to the whole derivative and you'll be good there. So I'm just going to leave it outside, and then I'll take the derivative of these functions on the inside. If you have questions, please pop up and let me know. Checking my blue dot just to make sure. Blue dot. Every time I navigate away, I lose what I was doing. Okay, there we go. Remember, the derivative of the natural log of u is u prime over u. So u prime in this case is the derivative of 2 plus x, which is 1, over 2 plus x minus, and then the derivative here, the derivative of 2 minus x is -1, and then divided by 2 minus x. And now this is just a matter of simplifying your expression. So I'm going to work on simplifying this a little bit. 1/4 times 1 over 2 plus x plus 1 over 2 minus x. Might as well rewrite that minus a negative using a plus. And then to get these combined into one fraction, you got to think back to algebra. Leave the 1/4 right here where it is. If you want to combine these, you need a common denominator. So you can write your denominator as 2 plus x times 2 minus x, And if you don't remember how to build that, it's fine, I will show you. You already had the 2 plus x. In order to make an equivalent fraction, you're just going to multiply by whatever quantity you needed. It was missing the 2 minus x. So of course you could go back, cancel it out, and you'd get back what you started with. Same idea over here. You're going to want the LCD to be 2 plus x, 2 minus x. It's always the product of all the unique denominators, the least number of times they appear in any one denominator. Okay, so same idea here. And then combine your fractions into one. So 2 minus x plus 2 plus x divided by 2 plus x times 2 minus x. I'm really bringing back the intermediate algebra here. The 2 plus 2 gives you 4, and then the negative x plus x give you no x's in the numerator. And then if you want, you can even rewrite your denominator, cancel those 4's, as the difference, or you can expand it out. Right now it's written as the difference of 2 squares. But if you went ahead and expanded that by foiling it, first the outside and insides will cancel, and the last will give you x squared. So it would be 1 divided by 4 minus x squared. So this one, the derivative itself wasn't as big of a deal once you rewrote the logarithm. It was simplifying to get an answer that didn't look, I don't want to say crazy, it wasn't that crazy, but just trying to make that look a little bit better, combining it into one fraction. Now, technically, you didn't have to rewrite this logarithm the way that we did here. It's just that if you didn't rewrite it, you'd be taking u prime over u, and u prime would need the quotient rule. So you'd be in a much messier situation. You could still do it. It just would be more work. Questions on that one or any other questions? And I will be posting these notes, by the way, as soon as we get done. It takes such a small amount of time to scan and upload this. I'm just going to have to go through and make sure they're in the right order, but oh well. Go ahead, Morgan.
Can you do something from 3.2?
Sure. Do you have one in mind?
19 on the homework.
Sure. $2.19. Actually, you know, I did this one in a different office hour. I can still go over it. It's not a big deal. I think I did this, I don't know, when we last saw each other, last Thursday, maybe. So this is e to the square root of x squared minus 25. I'm going to rewrite this so that it has a rational exponent on it. It's going to help us take the derivative much more easily. So this one's going to need the chain rule. First off, I'm going to take the derivative the way I normally would if it was just e to the x. But it's not e to the x, clearly. And then I'm going to chain on the derivative of the inside function, which is that one. So I'll do that in the next step. And if you want to put that radical back on, since you're kind of done with that at this point, go ahead. The derivative here is going to be bring down the exponent, 1/2, keep the inside function the same, subtract 1 from the exponent, multiply by the derivative of the inside function. So that was double use of the chain rule. So the power came out front, rewrote the inside function, subtracted 1 from the exponent, and the inside function still had a derivative, which was 2x. When you do that, notice that the 2's will cancel. One of them's in the numerator, one's in the denominator. Now, this is a negative exponent on x squared minus 25, so I'm going to move that into the denominator as a positive 1/2. And then if you would like, you could even put the radical back on that. You don't have to, but it matches that way at least. Oh, I lost the x. Sorry, the x needs to go there. This one. It's really easy to lose stuff here. Okay. That was 3-2, number 19. Other questions or questions on this one? We have like 7 minutes, so there's time. Don't be shy.
I have a question
Yeah, go ahead.
on number 14 and 3.3.
Okay. 14, 3, 3. Oh, I pulled up the wrong one. Wrong one. Okay. 14 and 3, 3. Okay. Ooh, that one looks like a doozy. Use implicit differentiation to find dy dx. We have minus 70. Yours might be not as crazy. Inverse tangent y squared minus pi x cubed y, little product rule there, equals 4 pi. Well, the nice thing is the 4 pi, yours might be a different constant multiple. That derivative will be 0. So I'm kind of thinking ahead as I work through this. But yeah, it doesn't have anything about finding an equation of a tangent line. Oh, I lost it again. Yeah, just, I don't know. Too many windows. Oh, there it is. Just use implicit differentiation to find dy dx. Okay. So let's see. Inverse tangent y squared. Well, first of all, the 70 is your constant multiple. The formula for the inverse tangent is u prime over 1 plus u squared. So u prime, be careful here, is 2y times dy dx divided by 1 plus u squared. So that term is a little bit on the trickier side. But there was no product rule, at least in that one. The second term is going to be a little tricky too, not only because you're going to need the product rule, but because when you use the product rule, you're going to have to remember to distribute this negative sign because you're going to have more than one term. So I'm going to let this quantity be f, and the y will be g. So when we take f prime g, the g is just going to be y. There's not going to be a dy dx on x. I'm not taking the derivative when I do f prime g. So f prime, remember the pi is a constant multiple. I'm going to put parentheses around it so I remember to distribute that negative sign. F prime is going to be 3 pi x squared. Here's your f prime g plus f g prime, then the derivative of y is 1, and then chain on the dy dx. I know some people were unsure of a couple of things relating to that, like when is it just dy dx? When is there a y that's included? Well, the derivative of y is 1, chain on the dy dx. So the derivative of y is dy dx. So f prime g plus f g prime. And then on the right-hand side, the derivative of 4 pi is 0. Okay, so lots going on with that derivative that could have gone wrong. I'm going through mine and double checking it now just because I want to make sure before we proceed. Let's see, u prime over u, 1 plus u squared, okay, minus f prime g plus f g prime equals 0. Okay. So far, so good. Let's try to simplify what we can. We'll have 140y dy dx. And if you want to have the dy dx kind of chained onto the end, then you can just write it like this so that your 1 plus y to the 4th, because we're taking a power to a power, we multiply the powers, is in the denominator. And then this guy will just be tagged along. Minus 3 pi x squared y. Don't forget to distribute this minus sign into your parentheses. So we'll take minus pi x cubed dy dx equals 0. And now I'm going to leave all the dy dx's on the left and all the non-dy dx's on the right. So if you'd like, since they're both already on the left, you can go ahead and factor out the dy dx. That leaves you with 140y divided by 1 plus y to the 4th minus pi x cubed equals positive 3 pi x squared y. So this term just moved over to the right. Then you can get dy dx by dividing on both sides. And there's your complex fraction right there. How did that change to a plus? It didn't. And then go ahead and multiply each term by your LCD, which in this case is 1 plus y to the 4th power. And honestly, if you leave this factored, it's fine. There's no reason to distribute that. All right, 140y minus pi x cubed times 1 plus y to the 4th. I mean, you could go on for a long time working on just finding random ways to rewrite that one. But I don't know. This looks fine to me. All right, it is 6 o'clock, so hopefully if you had a question, you got it answered, or at least if you didn't have a specific question, but you just kind of wanted to tune in to make sure you felt pretty good about it. Hopefully you feel better. If you have more to do, feel free to work on the review. It's optional, but it'll give you more problems to do. Otherwise, make sure you just have good notes ready. Everything is highlighted where you need it so you can find it easily for your exam. Log on tomorrow a couple minutes early so I can check your workstation. Email me if anything else is bugging you. And that is all. I'll post this video, and it'll take a while to process, but it'll be up at some point this evening. Okay. Thanks for coming to the office hour. I mean, I don't mind making the time for it if people are gonna make use of it. It's helpful. I hope it's helpful. Okay. Email me if you have questions, you guys. I gotta go. I got a babysitter coming over tonight, and she's gonna need someone to let her in. So. Adios.
Are you still having the office hour tomorrow before class too?
Yep. I'll be on around 5:30 tomorrow.
Awesome. See you tomorrow.
All right, sounds good.